Don't forget, right now, Jam and I are running a special campaign at our Ko-Fi. If you go to ko-fi.com/chemforyourlife and subscribe at any amount, Jam and I will send you a special Chemistry for Your Life sticker. That's ko-fi.com/chemforyourlife to learn more about why we're doing this and how to subscribe. And now, on to today's show. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
The podcast helps you understand the chemistry of your everyday life.
Okay, Jam, I promised you this episode a while back, and it's coming at you finally today.
Nice. Okay, I'm ready.
I thought of this in honor of Earth Day, and we're almost a month late, but it's okay. Chocolate just kind of took over.
And chocolate's also from the earth, which we talked about.
That's true. So it's sort of like Earth Day extended, Earth Month. So we're going to talk about what is the smell of fresh cut grass.
Nice. I've wondered that many times. There's just something very, very unique about it that really gets you, especially in springtime when lots of people start cutting their grass for the first time in a while. It's like it hits you just so strongly. Like you haven't smelled it in 6 months or something. And it's like, oh my gosh, what a smell.
Well, do you want to know what the smell of fresh cut grass is?
Oh, let me think. Let me try to decide. Yeah, okay, fine. Let's do it.
Yay! Well, I'll tell you, it's chemistry.
Oh, okay. I've heard of that.
Are you tired of that joke yet? I get excited every time.
I like making jokes back about that too, where it's like, yeah, I thought there was some science that could tell us anything about this, but there's not. So I guess we'll never know.
So what that smell is, if we're going to be more specific than just chemistry, is a group of molecules known as volatile organic compounds.
Okay.
Or green leaf volatiles.
Interesting. Volatiles.
So the word volatile just means it's in the gaseous form, or it's easy to become gas from liquid.
Oh, interesting. I did not know that's what that meant. Is that what it always means in chemistry?
Yeah, I think so. I mean, it just is something that's easily evaporated. So I think that is consistent in chemistry.
Dang, interesting. I feel like
I'm not positive. That's what I think of when I think of the word volatile.
I always have thought of it just as like sort of meaning like if I also use it in a non-chemistry way, I would think of it as something that's kind of fragile, but means that it could like I think if I described a person that way, it would seem like they might have like like their temper is kind of high or something like that. That's just what I have heard that word used in a very non-science way. So it makes it kind of hard for me to wrap my head around it in the actual way, the real way it should be used.
I can't think of anything off the top of my head like explosive. Volatile sort of means explosive in common language, but I don't think we use it as that in chemistry. I think of it as I keep it solely in that evaporating category in my mind.
Okay.
It could be, but I just don't think of it as that.
Okay, got it. Well, I guess that makes sense here too, because it's like if it's a smell and it's something that can turn into gas, then I see where you're going, I think.
That's right. So these are things that are easily turned into gas, these volatile molecules, and they hang out in the air, and that's how they come into contact with our olfactory receptors.
Nice. The olfactory.
The olfactory. These volatile organic compounds or green leaf volatiles, they are produced by almost every green plant.
Oh, okay.
And in fact, we're even going to hear more about those next week when we talk about Venus flytraps. Sneak peek.
Oh, dang. Interesting.
So that's what's really responsible for this smell of fresh cut grass. But if we zoom in even a little bit more and how these chemicals get into the air and why they get into the air more when we're cutting grass, what happens is actually pretty similar to what we talked about with the onion episode. When the cells are damaged, there are enzymes that will break down the membranes of the cell, and they'll produce two major organic compounds called linoleic acid and linolenic acid.
Oh, dang. That's confusing.
Yes. You don't need to know their names. In fact, I didn't even give the names for some of the other ones because there's just so many. But those acids are broken down by another enzyme into an aldehyde. And that's just a different type of functional group. So it's basically just broken down into another kind of molecule.
Okay.
And then it's even further broken down into an alcohol and even a different aldehyde. So you've got basically a soup in the air of aldehydes and alcohol and acids just floating around in the air.
Okay.
And all these together play a part probably in the fresh cut grass smell. But one of these aldehydes in particular, our noses can detect at as smallest concentration as 0.25 parts per billion. So
whoa,
barely anything, a quarter of a part per billion parts. So barely any of it in the air, and we can smell it.
Which that's like the smell of rain.
Yeah,
you told us about that, like that kind of sensitivity that we have is similar. Yeah. I can't remember what number you put to it, but it was like very, very small amounts were detectable by us. Wow.
Yeah, isn't that crazy? And
yeah.
So it's probable that is the main smell for what we think of when we think of fresh cut grass, supplemented by those other ones.
Okay.
So that's kind of the short answer. I mean, we could talk about all the individual molecules' names and stuff, but I'm not sure that would be as helpful. But I did want to say some other things about these green leaf volatiles that I think are really interesting.
Okay.
So they're always produced from plants in trace amounts, but they are produced much more rapidly when the cell is damaged, if there's damage to the plant.
Okay.
And that is what we saw in onions as well.
Mm-hmm. Mm-hmm.
And also, this is crazy to me. They are not only just like a smell that gets released because these molecules are being broken down, but they can actually act as a defense mechanism. And they do that in two ways.
Okay.
One, they let predators know that there's damage to their cell, which means perhaps a bug is attacking them. So they basically signal to a bigger bug to come eat the bug that's eating the grass.
No way. So
Yes.
Larger bugs basically would be able to smell that and might start associating it with like, ooh, maybe there's something down there that I could eat.
Yes, they smell that and know they're supposed to come eat it. It's a signal. And actually, one study found that a caterpillar chewing on grass released different green leaf volatiles that attracted a predator that eats caterpillars. So it wasn't the same as when we cut grass. That caterpillar specifically released a green leaf molecule that was different than just if we cut grass that attracted one of its predators to come eat the caterpillar.
Whoa, dude.
The grass is like, hey, come get this guy. Come get your friend. He's eating me. You come eat him.
Yeah. Man, dude, that is nuts.
I know. There's more.
Oh, yikes. Okay. I'm ready.
So these organic volatiles can trigger the plant to rapidly react to attack in one of two ways. So they use jasmonic acid, which regulates the nutrients in the plant, and that will either help them respond to damage or it can maybe change the nutrients so it makes one part less nutritious of the plant. So that helps it cope with damage.
Got it.
So it's kind of like our immune system. So not only are the organic volatiles calling in people to come eat their predators, but also it's the smell of the plant's immune system.
Huh. Weird.
And one of the organic volatiles is found to fight a fungus that infects plants.
Oh, man. Interesting. So they use this stuff, I mean, basically for lots of stuff. I mean, a defense system for people eating insects eating their leaves, and then fungus and man, interesting.
I know. Isn't that amazing?
Yeah.
Basically, the chemistry that we smell when grass is being cut is so much more complicated than just what we are experiencing. It's not just a smell, it's an immune system and a defense system, and it does all kinds of things.
That's crazy. And it's one of those things to this interesting to me because I think many of us just think of plants as pretty simple. And I mean, maybe you could make the case that they are compared to other creatures and stuff, but the idea that it's something on purpose at all is kind of mind blowing to me. And this has happened to me. We've talked about plants in the past, like how they keep from freezing and stuff like that. But or onions, which is, that episode still haunts me in a good way every day, every time I cut onions. But just realizing that these things are not just like, oh, this is the smell that happens when you cut grass, and you're just smelling the inside of grass. Mm-hmm. And it's like, well, sort of, but actually all of it's on purpose, and it's producing this smell for a reason, and actually produces it more whenever we cut it, and when cells are damaged, and all that stuff is just kind of crazy to me. But I often don't give plants much credit until I learn stuff like this, and then I'm like, okay, they have a lot more going on under the surface.
Yeah, that idea that you're just smelling the inside of grass is kind of what I think I always thought.
Yeah.
But it's a lot more than that, And I wondered too if maybe some insects would flock to where grass is being cut because they think maybe they'll get some prey or something.
Oh, yeah. I wonder if it's like so overwhelming to them too, because if they're used to smelling a little bit from a caterpillar chomping on like a blade of grass, I wonder if it like it just kind of makes it go crazy to smell the overwhelming, like literally every blade of grass just got cut. So yeah. But man, it's interesting.
Super interesting. I was very excited when I found all this information out. It's sort of a short episode. There's not a ton of chemistry lessons individually, but it's the function of the chemistry more that we're talking about today.
And I guess we've like in previous episodes kind of gone more into the nature of smell and stuff like that. Mm-hmm. So that might be worth looking back at. And I think one of them was, why does trash smell bad or something like that? Like, what makes bad smells smell bad? Yeah, it was just the most basic, but I guess we went a lot more into that then.
Yes. Well, do you want to take a stab at explaining it back to me?
Yes, I do. So, I can't remember. You listed multiple things, but then you said, this is the one we're more sensitive to, and I can't remember which one.
I didn't say the name of it. It was a type of aldehyde, but I didn't know that it would be super useful to say the name.
Got it.
For people who don't spend a lot of time in organic chemistry. So I just told you it was an aldehyde, which is a molecule that has a functional group on it, but I didn't really go into very much detail. Okay,
that makes sense. That's why I can't remember, because you didn't say exactly what it was, but basically, basically when we cut grass or when anything damages grass, and I guess you said this applies to other plants too, but we most commonly associate with grass. Its immune system and defense system has this built in where it will actually produce a lot more of these green leaf volatiles, and it has a few functions. To us, what we're probably smelling and have the most sensitivity to is an aldehyde that's part of that, but it's made up of a few other molecules and stuff. And it can signal to larger insect predators to come eat whatever insect is chomping at its leaves. It can help fight against fungi that are trying to kill it. And it's very much a on-purpose thing that grass is doing, and not an accidental, thing that just from us mowing our lawns.
That's right. And the only other thing that I think you kind of glossed over was the plant uses a molecule called Jasmonic Acid, which is a type of carboxylic acid, but that helps it change the nutrients. It regulates the nutrients in the plant, so it can respond to the damaged portions and maybe minimize the nutrients in another portion to help quickly respond to attack either by pathogen, so either disease for the plant, or if it's being attacked by an animal or something causing a bug causing damage to it.
Mm-hmm.
So it'll respond to attack either way.
Basically trying to move nutrients to the part of the plant that's not being attacked kind of thing. Like,
I'm not sure if it pulls nutrients from there to help first aid in the part that's damaged or what. It just said it will basically change the nutrient content to rapidly respond to attack.
Okay. But that is still interesting regardless, that plants are like something as simple as grass is making some moves like that based on what is happening to it.
I know. Isn't that amazing?
And it's just sitting there looking like nothing's happening all day long.
Yeah. It just looks like grass to us.
Yeah.
Man, chemistry really is everywhere.
It really is. It's just so funny how it looks so much like grass, though.
That's funny. Well, good job, Jam. You wrapped it up nicely with a little bow on it. Do you want to wrap up your week for us as well and tell us something that went on?
Sure. I'd love to. So one of the fun things about my week this week is that, Em and I always working on our house these days. And
oh, yeah. Got your new house.
Yes. And so we finally decided to change our desks. We used to have this like long desk that we made. I mean, we didn't make it like we just got some planks and some filing cabinets and stained them and all that stuff. So we've had that for years, probably like almost 5 years or something. But it didn't work quite as well in this room, and we were getting over it a little bit. So we finally pulled the trigger on that and got rid of that desk and bought 2 kind of small desks that you can adjust the height of them, and standing desk level or whatever. And I've had these before at jobs I'd worked in the past, which really spoils you. I mean, it's like I've missed being able to stand up and work so much. And so that's been really a highlight. It's like, I think anything that is a change to your workspace, though, is something that I've read a few articles that talk about that just being a positive thing. It kind of boosts your motivation, boosts some creativity, just because your environment changed a little. And so I feel like I've been experiencing that this past week of just enjoying being at my desk a little more and not being as annoyed at that old desk that was kind of wobbly, and one of the planks had kind of warped. And so I regularly got annoyed while working, and now that's gone, and I'm a little bit more just enjoying my workspace, and the health benefits of standing up while you're working are also a huge plus. So
yeah. Well, that sounds really nice. Yeah, I know how much time you spend working, so I feel like it's really important to have good posture and be not annoyed at your workspace all the time. So that's very exciting.
Totally. I definitely have horrible posture, so whatever I can do to trick myself into having better posture is nice. So that's me. What about you? How was your week?
My week was good. Probably the most exciting thing that happened to me this past week is I finished my last class ever.
Nice, dude.
It's done. I'm so excited. So, I mean, I'll obviously be a lifelong learner, and there's tons of learning that comes in research anyway, just reading what other people have written and stuff. So I'm not done learning, but I am done hopefully taking tests. So that's very exciting.
Yeah. Dude, that is awesome. Gosh, that's gotta be a great feeling. Many of us
is a great feeling
that didn't do more degrees and stuff have had that feeling for a while, and I cannot imagine really on purpose consciously going back into it. So props to you for doing that.
Neither can I.
But you've already done it. I mean, twice now. You're on your 3rd degree. So
I know. I'm a crazy person. And every time I said this would be it for me, after my master's, I was like, okay, I thought that was going to be it. And then after my PhD, I'm like, this is going to be it. So if I end up taking classes again, the joke will be on me. But I think I'm done forever.
Okay, good. Well, if there's anything we can do to try to convince you away from doing more school in the future, there's many of us who can help you with that.
Just remind me of homework, of what homework feels like. That's the biggest deterrent. If I just had to sit in class and learn, that would be fine. But the homework is the problem.
We'll just say hey, why don't you maybe don't learn more and do homework more, but instead just teach us more about chemistry. If you have this burning desire to do more schooling kind of stuff, just be the teacher for all of us, you put more into the podcast, I think, we'd all love that. So,
okay, I'll definitely do that. Thanks, Jam. Thanks for reminding me.
Yeah, pretty good excuse not to do more homework.
Yeah, it really is. Just I'm going to teach other people. I'll be the teacher. Then I'll just have homework for grading.
Yeah.
Well, thanks, Jim, for that encouragement. And thanks for coming and learning about grass. And thanks to all of you listeners for learning about grass as well. We literally could not do this without you. It is so fun to be able to come here and teach you guys about science every week.
And thank you for teaching us and for kind of unlocking the mystery of something that we all smell and are used to smelling ever since we were kids every spring and summer. Melissa and I have a lot of ideas for topics of chemistry in everyday life, just like something very everyday, like the smell of fresh cut grass. But we want to hear from you. What ideas do you have? What things do you wonder about? If you have those questions and ideas, you can reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chem4yourlife and donate the cost of a cup of coffee. And between now and the end of May, if you go and subscribe on our Ko-fi any amount monthly, Melissa and I will send you a note and an exclusive sticker to say thank you. But if you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to A. Hefner and A. Collini, who reviewed this episode.